Again, just picking up where we left off last time with our grade 9 assessment questions. So I'm looking at number 14, counting pennies. So we finished off, if you remember the last day, if I flip back a page, we finished off at this one here. Okay, so continuing on. So this one, we're given number of pennies and the total mass. So you would think that this would be like a direct variation where if you actually divided 60 divided by 4, 65 divided by 6, that would be the same number all the time. But the problem is they're actually sitting in a container. Okay, so that's the question. So we have identical pennies, so basically saying that they all weighed the same amount, are given in the table below. Okay, use the data to determine the number of pennies in the container when the total mass is 185, and it says justify your answer. Okay, so we could try to continue this to see if we could get a 185 and figure out the number of pennies. So we could do it that way, or we could actually maybe try to form the equation of the what the relationship between the two would be. So we could put some scale on here if you think that might help us. So this would be mass is our dependent variable, and the number of pennies was our independent variable. So number of pennies and what's our mass get up to? About we got to get up to 185. So looking at our scale, how would 10 work out? 10, 20, 30, 40, 50, 60. Not going to cut it. So I'm going to count by 20s here. So 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. And pennies, notice right now they're at 10. We probably got to get out to at least probably 20. So let's just see here. So if I count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that might even be a little tight on space, but we'll give this a go. And maybe that'll be enough information for us to come up with the equation at that point. So 4 pennies was 60. Next one we have here was 6 was 65. And 10 was 75. And you should notice they line up in a pretty good straight line. Actually, notice if I draw my line in here, I'm not even going to hit my 185. So let me backtrack here a little bit. Just changing our scale up a little bit. We'll count each one as a 2. So it'll be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 30, 40. Okay, so let's give this one a try here again. So 4 was 60. And I'll jump to the last one here, which 10 was 75. 10 was 75. And I can draw a line now. Off a little bit, I'll just slide it up here now. So we could get a rough idea of what the answer should be. So 185 would be, let's see, we're still off a little bit, but we can see that it's definitely going to be into the 50. So maybe let's go ahead and find the equation of our line. Okay, so to find the equation of a line, we have to know a couple things. We have to know the slope as well as the y-intercept. So starting with the slope, I'm going to look at our rise and run. Maybe I'll just draw in a little triangle here. So the rise in this case, we are going from going back to our table, remember I only plotted the final 2 points here, so we went from 75 to 60, or 60 to 75, so my rise is going to be 15 here. Problem when people draw it on the grid, they often would call that 1.5, but keep in mind each tick on our graph is representing 10, so that would actually be 15, and the run, remember that each one of these was worth 2 now, so that's going to be 2, 4, 6, so my run is 6. Okay, so slope equals rise over run, which equals 15 over 6. And reducing, dividing both by 3, we get 5 over 2. Okay. And I'm actually going to call it 2.5. I usually don't want to reduce my fractions to a decimal, change it, convert it to a decimal. But in this case, it's not a repeating decimal, so it's not too bad. So we know the equation. It's going to be mass. So again, normally it's y equals mx plus b. But instead of y here, I'm going to use m for mass. M, which we just found out to be 2.5. X is the number of pennies, so I'll call it n, plus b. So a little trouble here, because you could say, certainly looks like it passes through 50, but it might not be exact. So to find the b value, one of two ways. We can either kind of backtrack here. So dropping 4 pennies, we dropped 15. So dropping 4 more pennies, down here at 0. So, because this one was dropping 2, it was 5. So we should drop down 10. Yeah, and again, 10. So it should be 50 here, according to this. Because 6 to 4, so if you actually added in a 2 here, we would be at 55. So if you put the 0 in, we'd be at 50. So it does look like 50 here. So we get plus 50. Now the question is, how many pennies were there when it was 185? So we can go 185 for the mass equals 2.5n plus 50. And move the 50 to the other side. So we're going to get 185 minus 50 equals 2.5n. So we get 135 equals 2.5n. And the final thing we need to do is divide both sides by 2.5. So we end up getting n equals 135 divided by 2.5, and we get 54. Okay. And we can do a little therefore statement. So therefore, there are 54 pennies in the container. Okay, so hopefully that's okay. Again, we could have just continued our table. Notice they're going up by 4s. So we could have went 14. So extending the table, we could actually draw on a table over here. And they were at 1075. And they were going up by 4s. Initially, I know it was 2, but then the next jump was 4. So if we go up 4, 18, 22, 26, 30, 34. We're almost there. Not quite, really, but we get 85, 95, 105, 115, 125. And again, the reason I'm going up by 10s is when they jump by 4 here, they jump by 10 on this side. So we can continue that same trend until we get up to, we want to find out what it is with 185. Okay, so we would need 45, 55, 65, 75, 85. So it looks like another 5 of these along here. So another 5 would be, 5 4s would be 20. So it should be 54. And I think that was our answer that we came up with before as well. Yes, it was 54. Okay. Or you could plot it really neat on the graph. You'd actually have to, of course, again, either extend our grid or choose a different scale, but our scale is getting a little tight there to begin with. So especially when all the numbers that they gave us were so close together, like they gave us, the Y values were from 60 to 75, so a little bit tight for space on there. It wasn't like you got a point early on and then a later point out here where it would have been easier to graph. There's a lot more error if you plot 2 points together and you're extending a line, extrapolating. Okay, so flip in the page. So these will go a little quicker. So which of the following does not represent a line? So x equals 5 is good because that would just be a vertical line, because what's true at x equals 5? I have the tool to draw a straight line, so I might as well. So every single point on this line, x is always equal to 5. So we'd have points such as 5, 3, down here 5, -4. So the common theme here is the x's are always equal to 5. And this one here would be, of course, would be 5, 0. So that's x equals 5. So that's a line. Y equals 10, same thing, except it's going to be a horizontal line. This one's in standard form. The one that doesn't work here is when we have x times y equals 10. Okay. Now we won't actually ever really work with that. Maybe in grade 11 or 12 a little bit, but you'll see that it actually turns out, if you had a graphing calculator, you get something that looks like this. Okay, but not a line. So it was C. Okay, which of the following is equivalent to 4x minus 5y plus 12 in the form y equals mx plus b. So let's rearrange this thing. So I'm going to get negative 5y equals negative 4x plus 12. Sorry, minus 12. So I just move the 4x to the other side and move the 12 to the other side. So when we move them over, we go minus 4x and minus 12. Now I realize some of you, when you were solving equations, you'd actually minus 4x and minus 12 from both sides, and then do the same thing on this side. Or a lot of you were also realizing, hey, when I move this over, they're going to change signs. So the last thing I need to do here is divide by negative 5. Sorry, that wasn't the best pen to choose here. So I get y equals negative 4 over negative 5, which is 4 over 5 x. And again, a lot of people were holding on to the negatives here, but two negatives here just go to a plus, and 12 over 5. So it looks like the first one. Okay. Consider the equation y equals mx plus 5. If 7, 3 is a point on the line, which of the following is true? So they're saying the rise is 8, the run is 7, rise is 7, run is 8. So we're basically looking for what the slope is. Okay. So we're going to actually plug in, because remember m represents the slope. So we're going to plug in 7, 3, because you've had to do this in the past. Find the equation of a line given maybe the y-intercept, and then they give you a point. So what we actually have to do is figure out what the slope is, or I think the more common theme would be to actually figure out what the b value would be. But let's go ahead and plug in. So we have y equals mx plus b, or mx plus 5, sorry. And we're going to plug in 7, 3. So we get 3 equals m times 7 plus 5. Now m7 looks kind of strange, so I'm going to call it 7m plus 5, and I'll move the 5 over. Now if you guys would prefer, we can move the 7m over and the 3 over the other side, so I'm going to get 3 minus 5 equals 7m. So negative 2 equals 7m. Last thing I need to do is divide by 7, divide by 7. M equals negative 2 over 7. So I'm looking for a rise of negative 2 and a run of 7. Now they might actually say a rise of 2 and a run of negative 7, but I would imagine they have rise of negative 2, but let's go ahead and see. Yeah, the only one actually that has a rise of 2 anyway was C here, rise of negative 2 and a run of 7. Okay. 18. Which of the following again is not true? Okay, so we were given an equation in this form y equals mx plus b, so we know the slope is 3, or negative 3, sorry, and the y-intercept is 5. Okay, so slope is 3 is actually, that first one's actually incorrect. Let's double check with the other ones. Y-intercept is 5, yes, that's good. The rise is 3 and the run is -1. That would be true. Like if I actually wrote it as a fraction, I'd get 3 over 1 or 3 over -1, because actually if you found the slope of this thing, rise over run, we would get -3. Okay, so that's correct. And the graph crosses the y-axis at 0,5, which of course is my y-intercept again. So these all work. So yes, the first one was the incorrect one. The total cost of swimming at a community swimming pool is made up by a membership fee and a cost per swim. So that just says there's an initial cost, and then every time you go, you're going to have to pay some money. So again, this would be an example of partial variation where it doesn't actually start off at 0, would cost 0. Okay, so community center, Jake pays a total of $100 and swims 40 times. So we get a point that would refer to the point 40 and 100. Paula pays a total of $70 and swims 25 times. So 25, 70. Which of the following statement is true? The membership fee is $20. The membership fee is $30. The cost per swim is $250, or the cost per swim is $280. Okay, so maybe let's go ahead and find the slope, because the slope would represent the cost per swim. The y-intercept in our equation, because if we actually looked at finding the equation, let's go ahead and find the equation. See, be really interesting if two of these were true, because there's definitely maybe the membership fee is 30 and the cost per swim is 280. Okay, but only one could be correct. So let's go ahead and first of all find the slope. So slope equals rise over run, but I don't really have my rise and run so easily, so I'm going to go y2 minus y1 over x2 minus x1. So I'm going to go 100 minus 70, or I could have went 70 minus 100, but 100 minus 70, that way it stays positive, over 40 minus 25. So I'm going to get 30 over 15, which is actually 2. Okay, so that's the rate of change, or by slope, which would actually represent $2 a swim. So these are both incorrect. Okay, so now let's go ahead and have y equals mx plus b. So similar to the question we just did over here to the left, we now know that it's y equals. Now y is the cost, so I'm going to actually use c equals. And the m we just found a second ago was 2. Instead of x, maybe I'll use n for number of swims, and then plus b. So we're going to plug in one of the points that we knew already, 40 and 100 maybe. So the cost was $100. Number of swims was 40. And again, we could have used the other point, the 2570, and we get the same answer. So I get 100 equals 80 plus b. So by inspection, without moving the 80 over, I think we can see that b would equal 20, which is the initial amount. Like if you actually remember the b, if you actually drew out the graph here. No sense in having any negatives in this case. So this is number of swims. And we see the cost here, the initial cost would be 20. And then our line, of course, from here would go up to the right here. Okay. So did we have an initial cost of 20? Yes, here it was here. Okay. Similar type question. Local fare charges a $15 entry fee and $1.75 per ride. Dustin, actually not quite. Dustin has a $35 to spend. What's the maximum rides he can go on? So the cost in this case, maybe I'll just switch colors so we can kind of keep it separated from the one we just did a minute ago. So it's $15 initial fee. That's like my y-intercept, and $1.75 per ride. That's my slope or my rate of change. So it's going to be 1.75 n for number of rides, and then plus 35. Sorry, plus 15. Okay, so we're trying to figure out what's the highest n could ever be. So could it be 20? So go 175 times 20, then add the 15 on. Okay, well that's not quite $2 a ride, but times 20 would be $40. 15 would be 55. So I think that one's going to be way too much. So we could do it by trial and error, plug in 11 and 12 and see which one, or just simply put in 35 for the cost. Now, usually when this works out, it's not going to work out to be exactly that he gets 10 rides or 11 rides or 12 rides. It's probably could be a decimal. So let's go ahead and see what happens. So we're going to move the 15 over. So we get 20 equals $1.75 in. And I think I know what's going to happen here, but let's go ahead and divide. So yeah, I get 11.4. Oops. I almost wish it was 11.6. And then I think a lot of people would be jumping at 12, but does everybody agree 12 would make it go over that amount? So even if it was 11.9, we could only afford 11 rides. So the answer here would be B. Okay, I'll do one more page and then I'll stop and I'll have to finish the rest another day. Relationship C equals 60 plus 15N. C is represents the total cost of holding an event at a hall, and N is the number of people attending. So you can kind of see here the 60 is the initial cost, kind of like my y-intercept, kind of backwards here, and 15 would be the cost per person basically. So the maximum number of guests allowed is in the hall is 100 people. So N, the highest it can go is 100. So what are the minimum and maximum possible values for C? Okay, so what's the cost going to be? Okay, so let's say nobody showed up, but you've already rented it, you paid your down payment. What's the minimum it could be? So let's say nobody shows up. So that would mean N equals 0. So we know N is going to be from 0 to N equals 100. So let's see, worst case scenario, nobody shows up. We get 60 plus 15 times 0. Or maybe best case if you're paying for it. So cost is 60. Okay, so the lowest is 60. And let's see what the max is. So what, 100? So I'm going to get 60 plus 1,500. So 1,560. So there it would be here. Okay. So hopefully that one's okay. Let's try one more here. So one more open response. So consider the equations y equals negative 3 halves x minus 7 and y equals 2/3 x minus 4. Compare the lines. You may use the grid if you wish. So I would recommend graphing these. So let's go ahead and try graphing the first one here. Y equals negative 3 halves x minus 7. So that tells me my slope equals negative 3 over 2, which is rise over run. And my y-intercept is negative 7. So I can start with plotting my y-intercept, and then it says my rise is negative 3. So that means I actually want to drop down 3. 1, 2, 3, and my run is 2. Now it's too bad I can't actually do that again. I'm a little out of space here, but let's go ahead and draw in our line. Hopefully that looks okay. And the second one we have, again, maybe I'll pick a different color here. So we have a slope of 2 over 3, which again, remember, is your rise and run. That'll help us with the graphing part. And my y-intercept is negative 4. So the rise was 2, up 2 and over 3. 1, 2, 3. And again, I'll do it one more time. 1, 2, over 1, 2, 3. Okay. So compare your lines. So now they were kind of nice to us. They kind of talked about the direction. Okay. So the first one, line A, going from left to right. What do you notice about the line A going from left to right? It's dropping down. It's falling. Line B, oops, line B is increasing. So I could have said maybe increasing or decreasing for the first one. We also may have mentioned the word constant in there. Now, why was line A falling? What do we notice about the first one when we go back to the equation? We notice the slope here was negative. So I'll just put that in brackets here that it was a negative slope. And the second one, we notice that it's a positive slope. So positive slope goes up to the right, negative slope down to the right. Okay. Steepness. How does the steepness compare? Would you say one is steeper than the other? Like if this was like a ski hill, which one would be the faster run? So I would say the first one here, line A. So line A is steeper. Because again, what would we be concerned with, the slope or the y-intercept? Of course, it would be the slope. So slope was equal to negative 3 over 2, which is negative 1.5. Okay, line B is less steep. Slope was equal to 2/3, which if you actually divide, you'll get 0.6 repeating. So see how I realize it's negative, but that was telling me that it was falling or decreasing. But this has a bigger absolute value, we call it. So it has the bigger number, so it's 1.5 compared to 0.666. And the last thing they want us to do is look at whether it's parallel, perpendicular, or neither. So parallel would be if they're running in the same direction, which obviously they are not. Does it appear to be perpendicular? Yeah, I could argue that that looks like 90. Now, how do we find something that's 90 degrees again? Again, all going back to our slopes. So what do you notice about those two slopes? They have the negatives of one another, which we know is one of the important factors. And the other factor that we have to have is that it's a reciprocal as well. So instead of 2/3 or negative 3/2, it's now 2/3. So they are negative reciprocals, so they are 90 degrees. Okay, so perpendicular. They meet at 90 degrees. And we also note negative reciprocals. So remember, we had negative 3/2 and 2/3. Okay, and maybe I'll try one more. I'm got to run here soon. So yeah, this one's a neat one too. High school program starting a recycling program. They gave us the equation, the cost equals 48N plus 75. So you might start to realize, what does the 75 actually represent in this case? It's kind of like my y equals mx plus b. So we can kind of make that connection. The b is the initial amount. So maybe that was the cost to maybe get the paperwork in place or apply for the program, where the 48 is the rate of change. So that's going to be like the cost per bin. Okay, so they want to have a minimum of 12 recycling bins. Maybe they have 12 rooms in this school, and they have a maximum of $1,000 to spend. Okay, so it says, what are possible values of C and N? So we could just kind of say, let's say N equals 20 and figure out what the cost is, provided it didn't go over the max of 1,000. So we might want to, first of all, find out what the maximum number of bins is. We know the minimum is 12, and we could also see what the maximum is. Okay, maybe we can't spend a full 1,000. Maybe we can only spend $998. Okay, because maybe you know, we can't. Let's say it was 20 bins. Maybe 20 bins puts us over the $1,000 mark. So maybe we could only have 19, and 19 bins. The total would be again $998 or something like that. So let's go ahead and see what would happen if we plug in 1,000. See how many bins we could actually buy. So move the 75 over again. I get 1,000 minus 75 equals 48N. And then divided by 48. So a Oh, geez, that I wasn't expecting that, but that was that number we had here earlier. So last thing we got to do is divide by 48. Divide by 48. N equals 19 point, what was it, 19.2 or 19.3? Okay, so we know the possible values of n are, we have to have at least 12. That's the number of bins, so it's 12 to 19 bins. Even again, if that's 19.9, we can only go with 19 because 19.9, or sorry, 20 bins would actually put us over. Okay, so what's the possible cost going to be? So we got to look at what would it cost if we had 12. So again, our equation was 48n plus 75. And let's plug in 12. So 48 times 12. Oop, I don't think that's right. Oh, yes, it is. Yeah, 48 times 12, and then plus our initial $75. So 651. And let's look at what happens when n equals 19. Cost equals 48 times 19 plus 75. So final answer, 987. Not quite our 998, but in the vicinity. Okay. So the question did say, give us a couple of values. So these are the possible values of n. So it goes from n equals 12 all the way up to n equals 19. And the possible cost is going to cost a minimum of 651 up to 987. Now it said, what are some possible values of C and n? So we can plug any value of n here you want between 12 and 19. Remember, originally I wanted to plug in 20, but we would have been over the $1,000 mark. Okay, so if you want to use 1, we could say the n is 12, and the cost would be 651. Or we could say n equals 19 bins. The cost would be 987. Now we could also put in some other ones. You want to maybe go with n equals 15 and see what the cost is. Okay, and maybe it'd be nice if we actually summed it up with a little therefore statement. So therefore some possibilities would be, and so we could have 12 bins would cost 651, 19 bins would cost 987, and 15 bins would cost another whatever the 15 bins would cost. Okay, so hopefully that makes sense. We could even make a little table, and you'd notice that it's going up by the same amount. So you'd notice that it's going up by $48 every time. Okay, because that was our rate of change. Okay, so I'm going to stop there. It was a pretty long video. I don't know if I'll finish the last one. I think there's only a couple of questions left, so hopefully that's enough review. If you have some questions about them and you want to email me, that's fine, and I don't mind giving you solutions on the ones you can't get. Okay, so hopefully that was good. Okay, talk to you later. Bye.